I will speak a little bit about the hardware track that I will lead today. I myself represent Argonne Leadership Computing Facility at Argonne National Lab. And at LCF, my job is a performance engineer. And I am doing performance analysis of applications, performance projections, tuning, porting, acceptance, deployment, working with users, everything which performance engineer is supposed to be doing. I'm also LCF postdoc lead, so I'm working with our postdocs and mentoring them. Let me start from a wide range of perspective of what DOE is doing in HPC space for the last several years. In that slide, we have some sort of old machines that have been deployed back in 2012, where DOE decided to make a decision to split in between hybrid architectures, which Oak Ridge started deploying with Titan, the Cray AMD NVIDIA accelerated system, and Argonne continued deployment of IBM Blue Gene line, which is a many-core architecture based on 16 cores PowerPC A2. Similarly, Lawrence Livermore National Laboratory was deploying the IBM Blue Gene Q, which is twice larger than ours. Later on, the machines were upgraded. Argonne moved forward with Theta, which is still online. This is continuously being many-core architecture based on Intel's Knights Landing 64-core system. Lawrence Berkeley decided to have a hybrid architecture, still have many-core. It has Xeon partition and Knights Landing partition, both from Intel. At the same time, the Trinity was made, and that's also a hybrid architecture, very similar to what Berkeley is doing. Oak Ridge has upgraded Titan with Summit, which continues to be a hybrid architecture, and now it is IBM Power 9 based host and NVIDIA GPU device. Sierra is another machine of similar architecture at Livermore. Now we start deployment of the first exascale machines, and you will hear a little bit about the Oak Ridge system right after my introduction, called Frontier, which is an HPE AMD accelerated architecture. We are currently deploying the Aurora system, and you will also hear about this later today. The machine is made by Intel with the help of HPE. It will be using the hybrid Intel host, Intel device architecture. Lawrence Berkeley continues the same path, and it will be using the hybrid architecture with Perlmutter from HP, AMD, NVIDIA. And of course, there are a few other machines on Los Alamos, Crossroads, and El Capitan on Lawrence Livermore. So basically, the tendency is to move out of many-core architectures, and everyone is using a combination of accelerated devices from all possible vendors, including Intel, NVIDIA, and AMD. There is another thing which is happening in the last several years. We see the surge of scientific machine learning. So basically, we have the convergence where the HPC solutions are accelerated with the help of machine learning devices. So machine learning is used here in a variety of flavors, and one of them is really to have the surrogate models or replacement of heavy computations with machine learning acceleration. Also, there are data-driven models. But, what it happens is that we start accumulating too much information, and we do not have any power to process it. So we start using training to accelerate the processing of data. And then we have the co-design of experiments where machine learning helps us project what is going to be next, what we will be doing in experiments, what we need to be doing with computations, or we can use some computations for training and then accelerate the solution finding and then set up the new solutions. So all of this, there are a couple of examples here. The acceleration of the scientific learning is actually happening in all possible domains. So I here put some protein folding devices, the galaxy classification, many other things. Now we also have the integration of AI systems and facilities. So in this sense, we have experimental facility which is generating a lot of data, and we have a computing power which is processing this data. At the same time, experimental facility may need to have calibration, for example. In this slide, I show experimental facility picture, which is actually Argonne APS, Advanced Photon Source machine, one of the brightest X-ray sources in the world. And to make the photon beam calibrated and focused, it takes a lot of compute power. So we are actually using and start using our HPC systems in Argonne Leadership Computing Facility to help them build a better beam. Of course, at the same time, experimental facility might be generating the data which cannot be processed in place, so the data are stored in our machines and processed over there. And as I said, same thing as before. After the processing of data, experimental people set up a new experiment based on the knowledge that they can generate on our machines. Little bit more about AI for science. As I said, there are very many applications which now accelerated by artificial intelligence hardware. And this is the reason why we will spend a fair amount of time today talking to a variety of artificial intelligence vendors, and they will be presenting you their accelerators of their solutions for AI for science. And that's example of people who will be here. So we have a variety of vendors who will be presenting this, and I will be giving them time to present their solutions and their vision of how they will be helping high-performance computing and general computational science to build faster solutions, faster designs, faster experiments, or smarter use of experimental facilities. And finally, let me come to agenda. That's what we will be doing today. Right now, I am presenting this introduction, and then we will have a description of Oak Ridge Leadership Computing Facility from Oak Ridge National Lab, and Tom Patador will give us some understanding of what Summit and Frontier are. Then we will have Samanti Kasuri, who will show us the vision of Samsung on new memory technology and how we can use them for accelerating AI or HPC or both. Then after a short break, Andrew Link will be presenting the Grok solution for artificial intelligence. Mailin Pandit will be presenting Habana, another artificial intelligence accelerator vendor. And Urmish Trahar from Sambanova will show his company vision on how we need to accelerate science with their AI solutions. Richard Ball will present GraphCore, another design for AI. Then we will have lunch in cafeteria. And after lunch, Andy Hack will be showing Cerebrus solution for AI. Then we will have an overview of future Argonne system at Argonne Leadership Computing Facility from Servesh Muralitharam. That's going to be a talk about Aurora system, which is coming. We expect Kate Underwood showing us the slingshot solutions from HPE. And then Yuri Alexeyev will give a talk about quantum computing. We will have a question and answer session today for 1 hour at 4 o'clock. So this is done so that we could have a little bit longer conversation with vendors, because during the very tight schedule, it is very difficult to keep up with longer conversations. So I suggest if you have a very quick question, like yes or no, that's fine to ask after the talk. But if you want to suggest a longer discussion, send me a message. I will be checking my email constantly, morozov@inl.gov, and I will be collecting all the suggestions, and then we will have a more productive conversation during this time. And basically, this is what I just said. Please ask questions if that's just a clarification, or please send me a discussion suggestions by email.